everyone. My name is Andrew Hatch. I currently work at Seek. I do manage the DevOps team. I know that's not a team, and I'm going to go into a bit of that, and we are going to change it. Thanks, Mr. Redbubble, wherever you are. So anyway, so a bit of background. I do work at Seek. For those who don't know, Seek is based in Melbourne. We build all our product in-house, so we use contractors. We don't outsource delivery to vendors and things like that. So we currently were founded in 1997, and we have over 700 people down there on St Kilda Road. We still run a bunch of our legacy systems in a data centre in Sydney, but since about 2015, we're putting a lot of our code into AWS. Bit of background as well on what we're currently at. We now have over 15 programming languages running in production, which is actually a fair jump from where we were a few years ago. We do run Windows and we do run Linux. Again, a fair jump from where we were. We have what we call now, pretty much self-sufficient teams. They pretty much do everything themselves. They do their own builds, deployments, support, product people, integrate with their customers. We're trying to get rid of as many silos as we can, and they favour APIs, rather than shipping code libraries and dumping things on servers and hoping it all hangs together. We do around 500 production changes a month, so that could be complete website rebuilds, that can be changes, and we currently have about 80 accounts in AWS. That's not a great thing. It's beginning a bit of a pain to manage, but we seem to be managing at the moment. What this talk's going to be about today, it's not going to be tech heavy or anything else. I'm going to focus on sort of the three main areas, which is your people, processes and tech, and sort of for Seek how that's worked for us over the last few years. So don't worry, it's not going to be one of those ones. What I'm going to focus on is the last 4 years, and so where we came from and where we've got today and how we actually managed to do that. 2013. So in 2013, we were Agile. We'd been doing Agile for a while. We had cross-functional teams, so we had product people sitting with developers, sitting with UX people, but we only did that in our product and delivery streams. And our product delivery streams, I like to think of them, they were sat on this island. And in each of these islands, they all lived in their own little castles. They didn't really share things very well, and often if they needed to use something another team had built, they just copy the code and deploy it with their stuff. So we ended up with like 3 versions of the same site and all kinds of horrible things like that. The other problem we had was that our operations teams, they lived on a separate island as well. And there was a fair bit of distance between them, and getting across them was pretty bloody hard, depending on which side of the fence that you sat on. And our operations teams likewise also worked quite in silos as well. So there's a big problem with this model. It's pretty much, we're saying to everyone, you're free to build your code, you're free to test it, but you certainly can't deploy it or support it, which pretty much meant, that we ended up with having a love affair with a particular vendor and built everything on their platform, and we built a monolith, and that's what our systems used to look like. And of course, on one side of the monolith, we had a superhero culture, which is pretty much there's only a select group of individuals, and they just knew everything, so you didn't do anything without going to those individuals first and making sure you weren't going to screw something up. And in operations, we had a bunch of firefighters that were just running around constantly putting the fire out, trying to work out what was going wrong. This led to other challenges, namely that our ops teams policed everything that the dev teams wanted to put into any of the environments. And the reason is because they saw it as a grenade coming over the wall every time they wanted to do a release. Right? This is a familiar story for a lot of people, and it was for us too. Remember, we've been around since 1997, so we've built a lot of legacy despite the fact that we're a very online digital business. Other problems, ops guys don't want to know about what architects want to do. If it's not running on that vendor's platform and using their technology, we don't want to know about it. It's better the devil that we know. And so you can imagine C&B was a bit of a battle, at a lot of the times. The other thing that we also had, because production and staging were governed by our ops teams, it also meant our dev test environments were too, and they were always on fire because the ops guys guarded them as well. So, long story short, we had a lot of problems. There's a good book on strategy, and it kind of defines an organisation as like a big chain link logic system. So in our case, we had a large chain. It took a long time to get through every link in the chain to get what you want to do, and often you would have inventory building up at the chain that can be, releases, waiting to get deployed, waiting to go into environments, trying to coordinate and do this big song and dance to try to get everything going in there. And that was before we got into production, which, as you can imagine, was incredibly well guarded by the operations teams because it used to give them no end and no sleep. And we were doing about 2 production deployments a month. And this pretty much meant taking the whole website down offline, doing it late at night, not really shipping things very quickly. Not a great scenario to be in. So, sum it all up. Long time to get a release out to production. Work in process times were massive. And we built a lot of waste and technical debt. And that all sounds bad, right? But it was a product of our culture. So in operations worlds, where you favour stability and resiliency, where you're focused on costs, that generally drives a big bang project approach in delivery, and generally a lot of command and control, leader follower sort of management structures to try and keep the whole thing in check. So in other words, we were just doing what pretty much our structure, our hierarchy, our tech, and the way we did things, this is what it created. This is the outcome that you get. So where did we change things? The first thing is we thought, well, this isn't great, so why don't we actually get our ops people actually working with our delivery people? This sort of was where the foundation of a DevOps team sort of came from. But effectively, why don't we actually get them working with the delivery teams, actually anticipating what they want to build, writing the scripts, preparing the environments, so they're not just hitting a brick wall every time they get down there. Our processes. Find the bottlenecks, reduce the waste, and reduce the technical debt and the time it takes to do things. This led to, things that just seem completely bloody obvious now, but back then we deploy a website with a bunch of PowerShell scripts for Windows, so we brought in a deployment tool. The other challenge that we had with our ops teams was that we were running in a data center and we had to change that. Lucky for us, a massive American company opened a data center in Sydney, and we saw this as a very good opportunity to go, you know what, we're not going to be constrained anymore. The possibilities have opened up for us. All great. 2014 came around, and we had a lot more competitors in the marketplace at Seek than we actually were used to in the past. Seek had market dominance for a long time. Along comes Indeed, along comes LinkedIn, lots and lots of money, lots of international backing. If you haven't worked out, the online employment market is very lucrative these days. So what did we do? We need to get stuff out faster, so we increased our headcount by 40%, which means we had to increase our ops teams to go along with that and the amount of people in there to start actually shipping more product faster and faster. Our clunky deployment tool, we upgraded. We actually put it on the platform it was meant to, not Windows, but on Linux, and we brought in other deployment tools as well, so we could speed things up and go faster. I'm not going to name the product, so I'll do it later. And our other thought was with these dev test environments, why don't we just put them in AWS and we're not managing a bunch of VMware servers? That's going to be an interesting tale. But there's problems that we faced, even through doing this. The one is, where do we find these unicorns? How do I find someone who's from a software engineering background that has an operations skill set or vice versa? Those people are actually very, very hard to find, and especially when we're going to tell them you're going to work on Windows, which generally anyone from that background, me, was very late to the party with a lot of these kind of products. So, it was very hard to find software devs that actually knew this stuff at all. I'm from a software development background. I was a developer and architect for years and years before I moved into this. Our other problem was sending all these builds to our monolith. It was on fire, and when it's on fire, the monitoring system was setting the pager off, which pretty much meant someone like myself was managing a team of zombies every single week. It was kind of like The Walking Dead some days in the office, and some days I'd just be telling guys, just go home. For the love of God, just go home. You've been up since 3 a.m. But our AWS idea, we thought, well, with the dev test environments, why don't we recreate the monolith in AWS? Not entirely, but at least we can use the same IP ranges, we can use the same accounts because we put Active Directory in there, and we sort of will recreate it ourselves. And that all sounded like a great idea, and then maybe we could clone this. And so when people want dev test environments, they can just keep creating clones of the monolith so they can do their testing and they're not waiting. It sounded like a great idea, and it was a really good idea, but the challenges then became people started creating them, and they're creating more and more, and each of these environments had huge amounts of servers. And the thing is in the cloud is that because things don't start when you expect them to, things break in a tightly coupled monolithic system, so more and more got created over time, which had a very, very, very negative effect on our AWS bill. Set off red lights at budget time in our finance department. We were like, this thing's turned into a bit of a monster. So Ultimately, though, it did help us get more stuff out faster. But we did really realise that this switch, it doesn't frigging exist. You just don't just start doing this stuff and everything gets better. It actually got a lot worse for us for quite some time. But we did get up to 100 deployments a month, which was pretty good given that, our competitors were coming in with, faster sites, and we had to get more and more products out there. So the other problem, though, is with this monolith, right? When you have a monolithic system, it's like having a building stuck on crumbling foundations. And if you're just going to keep adding more and more levels to it, it's just going to keep breaking more and more. And so in our ops teams, we realised we have to get away from this. We can't just keep shoving more and more product on all these monolithic systems. We have to do something differently. But we're smashed at the same time too. We've been awake all night. We have demands placed on us from all these teams. So what do? We need to find time. And we had to find time to reduce the amount of unplanned work, right? As we all know, unplanned work is the killer. It's the work you don't know that's coming. It's the production incident that happens at 10 o'clock in the morning and you have to drop everything. And boring work, things like just doing deployments. An ops guy who's got a wealth of experience doesn't need to sit there and press a button on a deployment tool. At least they shouldn't need to be doing things like that. So what do? The one thing is with our people is that putting them in the streams actually works really, really well. But what we found in some cases was that there was just like this DevOps side to the Kanban wall. So while the ops guy might have actually been in the team, they were just sitting there doing the ops work. And so people weren't actually in the team, weren't learning. I've got a problem, ask him. I've got a problem, ask him. They weren't actually learning how to solve the problems themselves, right? So we thought, well, this kind of sucks. What can we do? Why don't we change the way we do things? Why don't we get our ops guys to actually teach the devs how to do this kind of stuff, how to do deployments, what a monitoring system looks like, what kind of skill sets and how you think about how systems work rather than just writing code, because a lot of developers at the time, they're worried about programming languages, algorithms and business requirements. They're not generally thinking about scalable state and multiple servers and uptime, downtime and CPUs and memory burning out. It just doesn't factor into your head all that much. And ultimately, how can we teach them to drive these deployment trucks themselves? The other solution that we came up with at the time too in order to stop this was our monitoring system that was just turning us into the walking dead every day. How can we do this better? We had this idea that a monitoring system should tell you when something goes wrong. And we sort of thought, well, why don't we come up with a better monitoring system? We call it the Monitron 5000, but effectively what it is a monitoring system that is going to detect when things go wrong, and it's going to put the fire out before it actually sets a pager off in the first place. So when a pager goes off, you know something's really, really wrong. That took a lot of effort. It took a lot of custom scripting because, especially with Windows systems, there's a lot of Windows remoting and PowerShell and all this kind of crap. And not to mention as well, that you want to tune monitoring systems as well. You don't really care so much if CPU is running at 90%. That's actually okay. It's a problem if it's been doing that for the past hour. It might cool down. It could be a spike in load. Someone could be trying to attack us or something like that. And then we thought, well, what about infrastructure as code? Why are we going through these arduous processes of building servers? We found some time, we wrote out some DSC scripts, and we got building a server from 3 weeks down to 30 minutes. For those who don't know, in the Windows world, PowerShell DSC is desired state configuration. It's infrastructure as code, for want of a better word. Next step, AWS. So we've kind of been burnt with our dev test environment. So how can we use this better? What we want to do is we want to be able to make deployments in AWS. We want to move to production in AWS, but we don't want to do it in the same way that we've always done it. We don't want to create the same problems. We want to make things better. So we came up with this idea. And we thought, why don't we actually devote a couple of ops people into an actual delivery stream, and we're going to coach them from the start how to do it, how to do their own monitoring and their own pager support, how to do their own builds, and how to do their own deployments into production. Now, I realise production system in AWS, like, big deal. Who cares, right? Everyone's doing it nowadays. This was a big deal for this business. This was a business that was used to data centres, was used to hardware refresh cycles and procurements. It was used to, long-winded depreciation cycles, all those kinds of things where we just deal with the vendor and we engage them and we pay a cost. Now we're doing it all on our own. What if the cloud breaks? Is the cloud secure? It's pretty expensive. Did you see what happened in the dev test environments? What are you going to do there? That wasn't easy. We had a lot of conversations. Luckily, we had some pretty good execs that backed us on this decision. This actually turned out to be one of the most stable systems we ever built because we took this approach and we thought, yeah, we're onto something here. This is kind of working for us. How can we make it better? So then the idea is, well, why don't we just create a team that wholly and solely has operations people in it? They're not loaned or on borrowed, but the skills are actually brought into the team and they create it themselves. And then we thought, same thing again, you do your own support, you do your own monitoring and everything else, but you're going to focus on building things in a more service-orientated microservices. We just call them right-side services. No one can accurately define me a definition of how big something is before it's not a micro or a macro service. We just call it right size. And also we said to them, you can build it on whatever the hell you like. Docker's this thing that everyone's tweeting about. Go build it on Docker if you want. Run it on Linux. We don't do much Linux at the time, we do now, but do whatever you want. But the other caveat that we wanted to this as well is we said we want a continuous delivery pipeline. We want to be able to check in our code, get it built, get it tested, get it in front of our customers, and all in around 20 minutes time. 20 minutes was a bit of a stretch goal for some teams, but other teams actually made it. And this worked really, really well. I mean, like, this is actually pretty cool. One thing is we're no longer doing CMB with these teams. It's just a Slack message. They don't, or an email, for example. We don't need them to come and plead their case. They're supporting everything. They own all the tech. They're completely self-sufficient. And so this massive chain link system that we had for our existing systems had pretty much shrunk down to a nice smaller chain with equal links of equal size and weight, because we were actually focused on every part of the process, not just having one team responsible for one part and one for the other. That's how we got to 500 in a month, by doing that. Our other thing that came out of this is that when the team is responsible for everything, we still get incidents, that still happens, but the time to resolve them fell through the floor. So we weren't having things where we're up at 3 o'clock in the morning building an MSMQ cluster. We just don't have those problems anymore. We don't measure incidents in hours anymore, which is a great thing. Then we thought, and people were saying, well, why don't we lift and shift the monolith? Why don't we give it another go? And we thought, we're not going to do that. That's just a dumb idea. So our monolith kind of looks like this now. Basically, we take bytes out. If we have to modify something of significant size, we'll lift and shift it into AWS, putting through continuous delivery, speed things up, everyone's happy. That's our process, and that's what we follow now. The big advantage for the operations team, and that is we got our time back. We get our time to actually send a whole bunch of crap that have been sitting around for over 10 years to the tip, cleaning up old servers, old DNS entries, old host names, stuff that you wouldn't even believe if I told you what we had lying around in there. We started to think smarter about what we were doing and brought more automation into the things that we were doing. We were starting to think like devs, which was always our goal, is that we wanted an operations team that thought like developers thought, brought software engineering principles into what they did. I read this great book quite a while ago, recently, the Google SRE book, and I thought, yeah, actually, that was the approach that we took too. It took us a long time to find software engineers that wanted ops skills, but it was really worth it in the end. And also our finance department. So one of the things we've done is in the past, when AWS bills came in, our finance department would tear themselves in a knot. Reserved instances, are they CapEx, are they OpEx, how do we accrue, how do we assign all these things to these teams? We built this gargantuan spreadsheet that crunches all our bills, and we've since handed over our finance team, I'm happy to say, did the bill processing for the month of April, and they barely needed any oversight at all. So that's another bottleneck removed for our finance team, who are constantly asking us, can you please do the bill, can you please do the bill, we've got to close out the month end. Which always sucked because it pretty much meant I couldn't go on holidays if there was a Friday or month end involved. This is the best part. We got sleep. We've got sleep, we're happy, we're rested. We had 4 babies born into the team. People are, enjoying life outside of work. It's awesome. So one of the things that we learned, a lot of things we learned out of this, right? And I guess this is pretty easy to say, is that the cloud is designed for consumption. It wants you to consume more and more and more. This is what they want you to do. They're constantly releasing things more new and every day. The way we build a solution right now in AWS is fundamentally different to how we would have done it 2 years ago. We all know that, which means it bites you on cost. This is one of the things that we've learned. In other words, it's hard to sort of have conversations with architects and devs and say, we don't need a monster truck, guys, we just need a Vespa. That's all we need. It's not all the shiny things and you're not a magpie. And the other thing that we learned too is the cloud actually breaks. So it has incidents and it will screw you over. So when you have incidents when say S3, well, guess what? The SLA is 21 minutes a month. So you've got to build for that. You have to architect for that. You could lose your stuff. It could just go offline. And guess what? Amazon owe you nothing. This is what they put in their SLAs. You've got to read this stuff. Capacity is not guaranteed. I know they say they have infinite capacity, but ask the guys in the Sydney data centre that for the last 2 weeks, and you can't get a C4 large to save your life because they ran out of capacity. So how do you plan for that? You need to think about how your pipelines work, your deployment tooling, so you can chop and change instances if you like to. I guess what I'm trying to say is, from my software engineering background, non-functional requirements, they're still a thing. They really are a thing, and there's some things you have to think about when you're building solutions. Don't build it with the thought that providers like AWS are never going to cause you grief, because they will. Your vendors. Don't get held captive to your vendors. We used to have a lot of big vendors that with long contracts and stupid 60-day clauses in them and things like that. When the platforms are moving fast, you want to be in a position to churn and burn your vendors. If they're not giving you the value, you want to be able to get rid of them. You don't want to be stuck signed up with some stupid agent-based model that, when you want to move away from EC2 because you want to move into Lambda and it doesn't suit you anymore. This is really important. The platforms are moving fast. If you want to move fast, your vendors have to move fast too as well. It's a big race for a lot of them. So, what have we learned? We've learned DevOps is obviously about culture. We've all been saying it. I won't go into it. It's definitely not a team. I know that, and I appreciate the irony of my position. And it's organisational in focus. And the reason is because cultures are unique in all organisations. They're like snowflakes. They're built up of people. They're built up of customs, traditions, systems, just personalities, workplace norms or just activities. That all creates an organisation's culture. So, these things like the DevOps instruction manual that someone might tell you, or the ultimate DevOps tool that a vendor might tell you, these things don't exist. They're not actually real. It's not that at all. And likewise, you have to focus on the whole chain. You don't just want to inject DevOps goodness or whatever you want to call it in each link if the other links are on fire. A chain's only as strong as its weakest link. What we've found is that you want smaller teams, releasing more smaller chains, and build those disciplines out. That for us has worked incredibly well, especially in a competitive marketplace. So one of the things that I like is, I'm sure most people might have seen this, is kind of the Spotify model that they do around alignment and autonomy on various systems and teams. So it sort of helps with organisations to actually see whereabouts do you fit on this. Now, coming from a background working in a lot of large corporates, the ivory tower was a very common thing. This is generally where a lot of people are waiting on a single architecture council to make decisions across absolutely every single development team, and you can't do this because we haven't approved it, and all these kinds of things. Otherwise, people are too afraid to actually do things but step outside the norm. If you're on low and low, you obviously need to find another job, and I work for a great company. You might want to check out our website. Of course, in the area of chaos, you can fall into this trap, especially when you're starting to consume more and more of the cloud. As I said, it's designed for consumption. You're going to start doing all different kinds of things. It's important, I guess, for those of us who are sort of overseeing a lot of these things, is that we're keeping an eye on how this is transposing. As we like to use the term sensible defaults at Seek. In order to get to where Charlie Sheen is, here's a few things that I've learned over my time at Seek. One is leadership. There's two types of management, and this isn't a good one. It's this one. It's where that you have people who are actually leading. They're actually doing, they're not telling people to do things they wouldn't do. They're actually getting down there and they're doing it themselves. They're the kind of leaders who will pick up a page when it's buzzing and try and help resolve things. Your focus. You can focus on the cost of anything. I remember once, many years ago, with AWS getting involved in an architect over the unit cost. But it's cheaper for me to run a VM here than it is for you to run an EC2. And I'm like, yes, but look at the total cost of ownership. Look at the effort required in doing that. In other words, focus on, is this going to get rid of waste and is this going to add value to the business? They're the right things you should focus on. Lastly is culture, which we talk about. A blame culture does not work. If people are constantly being, bashed around the ears because they're making mistakes, that's not a good thing. Learn to tolerate failure. Failure is okay. It's okay if you're learning something from it. Throughout this journey the last 4 years, without going into the details, we've made a huge amount of mistakes. We've done a whole bunch of things. If we went back on it, we go, yeah, we would do that again. Absolutely. But you know what? We learned from it. There's a great quote by a guy who did the Toyota production system when someone stole a wiring loom from Toyota. And they said, aren't you afraid that he's taken the whole blueprint, he's going to recreate the wiring loom? The guy was, no. He hasn't taken the 20 years it took us to build that wiring loom and all the mistakes we made. So by the time they actually get the damn thing to work, we'll be 12 months ahead of it anyway, and we wouldn't have used it. So all these things sort of build into it. The last thing I love this is read in the strategy book, and it is successful organisations. They know how to get the tension right between what we consider as decentralised autonomy and coordinated action. Now, it's fine and it's very flippant to go, just put devs on pages and then everything will be right. It doesn't work that way. One of the things that we've learned is that if you're going to push autonomy down, you need to raise the technical skills at all the levels that you're pushing it down to. It's just not a thing that people can just pick things up naturally because it just makes common sense. In a technical world, what we like to say is, you know what you can have is the languages you want, the platforms you want, that's fine. If you're going to support it, great, go ahead, that's fine with us. But you know what, we're still going to coordinate action around security, we're still going to coordinate action around, say, buying reserve compute and working with enterprise discount programs for the best of the business. And we're still going to aggregate data in a single place, so we're not having to trawl through 20 different or 40 different elk stacks to find where something went wrong and where its effects were. So to sum it all up, because I'm running a bit out of time, but the last three things that I've learned, that we've learned, is that doing this, buy-in has to be driven top down. It doesn't work if you're just one team trying to make change. This has to come from, you know, the top down. People have to want to change. You need to create a strong engineering culture, a software engineering culture in development and operations. You know, there's skill sets that need uplifts on both sides of the fence. And I guess lastly is that you need really good leaders. Leaders that keep you steered in the right directions. People that aren't chasing titles, that don't come with egos and want to build empires, but actually really want to help build the careers of those around them and actually make things better. So thank you very much for your time.